Force, work, and energy review 8. A 2 kilogram mass moves in accord with the velocity time function given there. At t equals 0 seconds, we're told the mass is at a position of x equals 0 meters. And here are some things that we want to determine. Initial velocity, position at time 3 seconds, and so on. Well, when you don't know what to do, do something. So let's start from the top. Initial velocity. Oh, well, that's going to be the velocity at time 0. So we should be able to do that in our head. Put a 0 in there. How about -5 meters per second? There we go. That wasn't too bad. All right. How about the position at t equals 3 seconds? If we want the position, isn't it true that we just want to integrate vt? Let's do that. If we integrate that expression, we're going to power up. Whenever we have a polynomial and we integrate, we power up. So that's going to be t to the third divided by 3. So that's going to be 2t to the third. We're going to raise that to t to the second power, dividing by 2, and that'll give us a 3 there, minus 5t. And then we need to put a constant on there. So that is our expression for a position relative to time. Sorry, I'm running out of room there. What are we told, however? We're told that at time 0, the mass is at x equals 0. So if I put 0 in for these t's, 0, 0, 0, we have x equals 0. Therefore, this constant of integration turns out in this case to be 0. Okay, well, that's kind of nice. So now let's put t equals 3 in there. Can we do that? If I put a 3 in there, that's going to be 27, 54. If I put a 3 in there, that's going to be 9, 27. If I put a 3 in there, that's going to be 15. What's that come out to be? 54 minus 27 minus 15 is going to be positive 12. That's where it's going to be. At 3 seconds, this mass is going to be at position positive 12 meters on our number line. How about part 3, the net force? How do you find net force? Well, net force is several things, but it's mass times acceleration, isn't it? And if we have the velocity function, we should be able to find the acceleration. So let's do that by taking the derivative. When we take the derivative with polynomials, we power down. Power goes down, 12t minus 6. How's that look? And the time that we're told is 3 seconds. So we put a 3 there, so that's going to be 36 minus 6. So the acceleration at that instant is a robust 30 meters per second squared. And therefore, the mass multiplied by that, the mass is 2 kilograms. So I think this is going to be 60 newtons of force. All right, how about part 4, the work done on the mass between 0 and 3 seconds, the work done. All right, how are we going to find the work done? Well, the work done is equal to the change in kinetic energy, so maybe we can find it that way. So that would be 1/2 times m times v final squared minus v initial squared. Now, this final and initial are for the time in question here, between time 0 and time 3. All right, so time 0, what is the initial speed? We figured that out to be -5. All right, so you squared -5, you still get positive 25. This v naught squared, that part there goes to be 25. What's the velocity at 3 seconds? Have we figured that out yet? We have not. So I think we should. Let's do that. Velocity at time equals 3. Do I have enough room? We can do that at the top. Here at the top of the page, let's put a 3 in there. You put a 3 there, that's going to be 54. Minus, you put a 3 in there, that's 18. Minus another 5. So that's going to be 54 minus 23. So how about 31? 31 meters per second. That's our final speed. We're going to have to square that. When we square that baby, That's going to be quite a big number, isn't it? It's going to be 961 or so. There you go. The 1/2 and the 2 cancels. So the net work done is going to be 31 squared, which is 961, minus 25. What's that going to be? 936. 936 joules. Sometimes with these problems, you just got to get in there and kind of get your hands dirty a bit and follow your nose. All right, what's the power that's being expended at a time of 3 seconds? Let's see, power is several things. It's work divided by time, which is maybe force times distance divided by time, and distance divided by time is speed. So you could say force times speed, and we want the power at 3 seconds. So if we have the force at 3 seconds and the velocity at 3 seconds, then we can find the power at 3 seconds. Well, the force at 3 seconds was 60, and the velocity at 3 seconds was 31. The force at 3 seconds is 60 newtons, and the velocity at 3 seconds is 31 meters per second. So at that instant, 1860 watts.